Today's presentation will be on the body's adaptation to bio-absorbable cardiac stents. For years, stents have been made of metal and plastic to facilitate health problems around arterial damage and the concern arising from myocardial infarctions and other health issues due to blockages of the heart. Scientists have also found that biodegradable metallic material, such as magnesium, have been made more beneficial in the body than permanent material due to the problem arising agent called the late stent thrombosis. Magnesium-based biodegradable material has the key advantage to reduce or even eliminate the late thrombosis. Magnesium has attracted most attention due to its role in many important biological functions and its biocompatibility. The job of the heart is to continuously keep blood circulating through the body. Blood vessels that supply the heart with oxygen-rich blood are called arteries. Blood vessels can narrow or block, restricting blood flow. In some cases, such as arterial appendages, blood can form a pool at the section of the heart and cause a blood clot. A procedure called balloon angioplasty with stent insertion is used to increase the blood flow in the section of the heart that is causing the blood clot. A thin tube is inserted into the arterial wall and guided to the heart. Once in place, it will release a balloon to widen the artery and the stent is inserted. As seen, the tissue surrounding the stent begins to produce a layer over the stent to form the cell wall. Bio-adaptation is the arrangement, subservient, specialized function to the needs and mode of the life of the species or the device. Either the implant, such as the stent in the presentation, or the bioenvironment around it, such as the human body, changes their response or properties to alter the vicinity around them. In the case of the bioadapted magnesium alloy stent in the blood vessel, the response to the stent implant within the vessel is a continuous structural adjustment of the vessel. The implanted stent must be longitudinally flexible to adapt to the blood vessel and its curve and have sufficiently low radial stiffness to prevent vascular damage. Previous studies have stated that the open cell design of stents is better than the closed cell design, as it provokes a better longitudinally flexibility for the vessel. The stent will expand and conform to the geometry of the vessel and the natural shape. Magnesium stent implants lead to changes in the geometry of the blood vessel, restoring the blood flow and alerting the wall shear stress, producing a low wall shear stress, which protects the surface from localized corrosion. On the other hand, if there was a high wall shear stress, this could lead to both uniform corrosion and localized corrosion. Flow direction of the blood has a significant impact on corrosion behavior of magnesium alloy stents. Research showed that the location of magnesium alloy in the artery also impacted on degradation. This degradation of the magnesium alloy stent is the most promising next-generation bioabsorbable stent. Magnesium wire implanted within the artery has a higher corrosion rate compared to the magnesium wire in contact with the blood. This is probably due to the formation of a calcium phosphate layer on magnesium wire exposed to blood flow. For magnesium wire implanted in the artery, they have contact with the matrix and the vascular cells, and the negatively charged proteoglycans in the matrix may repel the phosphate ions, thus impeding the formation of the protective phosphate layer. However, like any innovation, there are risks associated with the mechanism. Yes, the body and the stent both work together to adapt to the changes associated with the implant. However, it may take a turn and cause some harm also. The stent could have an effect on the local hemodynamic due to local enlargement in the arterial diameter when the stent is localized in the artery or vessel. Stent development can also cause arterial injury to the endothelium. The overexpansion of stents may lead to intimal denudation and medical disruption of the arterial functions. It may also provoke the production of growth factors of cytokines which contribute to the development of neointimal hyperplasia and restenosis. In conclusion, the body uses physiological needs to adapt to the changes of its local environment. Thank you for listening to the presentation.